Let's start doing some real coding in Python and see how you compute the mean, median, and mode using Python in some IPython notebook file we have. All right, let's actually put some mean, median, and mode in practice in some actual Python code. So let's make it real. Actually turn this into some real code using some data in an IPython notebook. So go ahead and open up the mean, median, mode IPython notebook file from the data files for this course if you'd like to follow along, which I definitely encourage you to do. If you need to go back to that early lecture on where to download these materials from, please go do that because you will need these files for the course. So let's dive in. What we're going to do is create some fake income data, getting back to our example from the previous lecture. So we're going to create some fake data where the typical American makes around $27,000 a year in this example, and we're going to say that's distributed with a normal distribution and a standard deviation of 15,000. All numbers I completely made up, and if you don't know what normal distribution and standard deviation means yet, don't worry, I'm going to cover that very soon, but I just want you to know what these different parameters represent in this example. It'll make sense later on. So to do that, remember to import a package into Python. We say import NumPy. We're going to use the NumPy package, which makes computing mean, median, and mode really easy, as NP, which means we can call NumPy NP as shorthand from now on. And we're going to create a list of numbers called incomes using the np numpy random.normal function. And these three parameters mean I want it centered around 27,000 with a standard deviation of 15,000, and I want you to make 10,000 data points in this list. Okay? And once I do that, I can compute the average of those data points, or the mean, by just calling np.mean on incomes, which is my list of data. It's just that simple. So let's go ahead and run that. Make sure you're selected that code block, and then you can hit the play button to actually execute it. And since there is a random component to these income numbers, every time I run it, I'm going to get a slightly different result, but it should always be pretty close to 27,000. Okay? So that's all there is to computing the mean in Python. Just use NumPy. It makes it super easy. np.mean. So you don't have to write a bunch of code to actually add up everything and count up how many items you had and do the division. np.mean, NumPy mean, does all that for you. Let's visualize this data to make a little bit more sense. So there's another package called matplotlib, and again, we're going to talk about that a lot more in the future as well, but it's a package that lets me make pretty graphs in IPython notebooks. So it's an easy way to visualize your data and see what's going on. So in this example, we're using matplotlib to create a histogram of our income data broken up into 50 different buckets. So basically we're taking our continuous data and discretizing it. And then we can call show on matplotlib.pyplot to actually display this histogram in line. Go ahead and select that and hit play. It will actually create a new graph for us there. And again, if you're not familiar with histograms or need a refresher, the way to interpret this is that for each one of these buckets that we've discretized our data into is showing the frequency of that data. So, for example, around 27,000-ish, we're seeing there's about 600 data points in that neighborhood for each given range of values. And outliers like this, there's a lot of people around the 27,000 mark, but when you get over to like 80,000, not a whole lot. And apparently there's some poor souls that are even in debt here at negative 40,000. But again, they're very rare and not probable because we defined a normal distribution. And this is what a normal probability curve looks like. Again, we're going to talk about that more in detail later, but I just want to get that idea in your head if you don't already know it. All right, so computing the median, just as simple as computing the mean. Just like we had NumPy mean, we have a NumPy median function as well. So we can just say np.median on incomes, which is our list of data, and that will give us the median. And in our case, that came out to $26,915, which isn't very different from the mean of $27,005. Since there aren't a lot of outliers, since this is a nice normal distribution that's expected, median and mean will be comparable when you don't have a lot of weird outliers. So just to prove a point, let's add in an outlier. So Donald Trump, I think he qualifies as an outlier. Let's go ahead and add him in. So I'm going to stick in, using np.append, some dude with $1 billion into the incomes data. There we go. So what we're going to see is this outlier doesn't really change the median a whole lot. That's still going to be the same value, $26,915, because we didn't actually change where the middle point is with that one value. But mean should change quite a bit. Aha. So there you have it. There's a great example of how median and mean, although people tend to equate them in commonplace language, can be very different and tell a very different story. So that one outlier caused the average income in this data set to be $126,000, almost $127,000 a year, but the more accurate picture is closer to $27,000 a year for the typical person in this data set. We just had the mean skewed by one big outlier. So moral of the story is, take anyone who talks about means or averages with a grain of salt if you suspect there might be outliers involved. And income distribution is definitely a case of that. Finally, let's look at mode. So we will just generate a bunch of random integers, 500 of them to be precise, that range between 18 and 90. So we're going to create a bunch of fake ages for people. Print them out. There you have it. Now, SciPy, kind of like NumPy, is a bunch of like handy-dandy statistics functions, so we can import stats from SciPy using this syntax. A little bit different than what we saw before. I'm saying from the SciPy package import stats, and I'm just going to refer to that as stats, so I don't have an alias like I did before with NumPy. Just different language, different way of doing it. Both ways work. And I'm going to say stats.mode on ages, which is our list of random ages. And there we have it. So in this case, the mode result, the actual mode is 84. That turned out to be the most common value in that array. Let's run it again. And it actually occurred 14 times. Now, if I actually create a new distribution, I would expect a completely different answer because it's completely random what these numbers are. So let's do that. In this case, the mode ended up being the number 22, which occurred 15 times. So very simple concept. One more time just for fun. It's kind of like rolling the roulette wheel here. This time we got 84 showing up 16 times. Interesting. There you have it, mean, median, and mode in a nutshell. It's very simple to do using the SciPy and NumPy packages. So I'm going to give you a little assignment here. If you open up mean, median, exercise IPython notebook, there's some stuff you can play with. So I want you to roll up your sleeves and actually try to do this. Here we have some random e-commerce data. So what this data represents is the total amount spent per transaction. And again, just like with our previous example, it's just a normal distribution of data, just like our income example. You can run that. And your homework is to go ahead and find the mean and median of this data using the NumPy package. Pretty much the easiest assignment you could possibly imagine. All the techniques you need are on the mean, median, mode IPython notebook. My point here is not really to challenge you, it's just to make you actually write some Python code and convince yourself that you can actually get a result and make something happen here. So go ahead and play with that. If you do have any trouble, post in the discussions for this lecture and we'll help you out, but it should be pretty trivial. If you want to play with it some more, feel free to play around with the data distribution here and see what effect you can have on the numbers there, and add some outliers, kind of like what we did with the income data. So mess around, that's the way you learn this stuff. Have at it, have fun. All right, I hope you rolled up your sleeves and actually played around with that code a little bit, get some confidence in actually doing statistics in IPython notebook there and Python in general. So with that behind us, let's move forward to our next concept, standard deviation and variance.